the extinction event is already in progress. So how do we turn back the clock? How do we transform the transformation that's already happening?
Still very much on this emotional roller coaster of being amazed by the innovation that's going into the area and just how big, how wicked, and how complex the problem of climate change really is.
It's all about the challenge, not technology for technology's sake. It's not technology for financial sake. We need to think about what are the biggest challenges to humanity.
Most people don't have the disk space in their brains to really absorb the enormity. We've been creating these effects unconsciously for a couple hundred years.
It's difficult for the human brain to think globally all the time in terms of making change.
But it is a beginning and we have to start somewhere. So sometimes I'm scared, sometimes I'm hopeful.
This work makes me really proud, to be honest.
A feeling that you're doing something right, you know?
There is a sense that most people have that they can't control it. But there's also a sense that there are certain words that then become good words, bad words. Everyone adopts something as their boogie monster.
Carbon's become a dirty word, right? But actually it's vital to our life, our food, all our materials, everything we come in contact with has got carbon in. So at the moment we've got an issue with too much of it being in the wrong place, and we've just got to readdress that balance.
So then you get the carbon back and then you can reuse it.
This is like the first step, because we want to try and get everything out of the exhaust stream as valuable.
So it will be like 20% or at least 10%. While we're removing the CO2 out of the air, out of the exhaust, we still need to figure out what to do with it. Like nature, like the trees, where that CO2 is actually used for something good.
CO2 has been seen so far as a waste. However, it's not anymore. CO2 is a carbon source, will be the future of the carbon sources because we will stop using fossil fuels, and the source for carbon to make the many materials we need for our welfare will come from CO2.
By stopping that carbon going into the atmosphere and converting it into something else, so what we call carbon capture use, and at the same time displacing the fossil fuel that would have been used to make those materials, you've got a double whammy effectively.
The fundamental goal of the RICE project, or the Reducing Industrial Carbon Emission project, is really to do something different, to approach the problems that we have in a different manner. The traditional way for academics to solve a problem is research.
So we're going to stick to that. Are these like accordions? So it's all very well a scientist in a laboratory in a university building something that's super innovative and super clever on this scale. Okay, yeah. Taking that into industry is actually really, really difficult. And this is known as the Valley of Death.
The sort of structure of the Valley of Death is that you on one side you've got laboratory work and what a university does. And on the other side you have commercial viability. And the idea is that your income stream is negative and you've got expenditure, so there's your valley, and you have to invest significant amount before you get out of that valley.
So the biggest challenge is actually, getting to that level that we can take a novel technology to the point at which it's relevant to industry.
One aspect that is very challenging for academia is to create that level of trust and link with industry.
If you want to have a real impact on the society, it is important that academia and the industry come together. We are trying to bridge that gap that is there.
And how do we de-risk it so governments, industry, managers, financial institutions, and even the general public will adopt it, use it, and accept it. So our original goal was to work at Tata Steel. It's the largest CO2 emitter in the UK. It's 20% of CO2 emissions in Wales, so it's a massive emitter. And they're a big consumer of a lot of the things, hydrogen and things like this, that we're the goal for the RISE project to produce.
So this is the CoAce bioreactor. It's a reactor that is taking blast furnace gas from the steelworks and it's turning it into acetic acid using bacteria from a municipal wastewater treatment site. Acetic acid you can actually use for biopolymers, bioplastics, you can turn it into lipids for animal feeds. Yeah. There's loads of different things that you can do with carbon instead of releasing it into the atmosphere.
The steel industry has always been extremely welcoming of partnerships and collaborations to help us with all sorts of things, not just our environmental challenges. So the CoAce project is a fascinating project. I know it's small scale at the moment and we'll see where it goes, but the opportunity to find out whether that project will actually work on an industrial scale is so much easier to understand if you can actually pilot it on a steelwork site with real blast furnace gases.
The best thing that ever happened to the RISE project is not doing everything at Tata. And I will definitely thank Hanson's and Valley especially and Rockwell. We went to them and said, look, instead of doing it all in one place, can we do it to multiple locations and can we put it here and put this here and put this here? The feedback we got immediately was so positive that these were industries that wanted to try something.
What we've spent is the last 2 years building and constructing an algal photobioreactor. And what we're doing is we're siting that bioreactor. As you can see, it's quite large. We're siting it on an industrial plant called Vale Europe Limited, and they emit a lot of CO2 into the atmosphere. And our algal photobioreactor then captures that CO2, recycles it and reuses it by growing the algae. Algae themselves are the fastest photosynthetic organism on the planet, which means they grow really, really fast. But they also contain lots and lots of useful materials that we can harvest and extract from the algae and then use them as products. So effectively then we're generating value from that waste CO2.
But there's so much potential here with microalgae. It's similar with petrochemicals. You can gain so many different products from it, from bioplastics to biofuels and even health food supplements. You need industry or government to take a little bit of a risk just for us to prove the point of going, look, this is what we can do and we can achieve. We just need to show it on a larger industrial site scale now.
Having run and operated at the site, what we can get a feel for is the capital expenditure and the operational expenditure required to run these plants in a true industrial setting.
Without the industry, the research is pointless. Without the research, how do the industry get access to these technologies? We work with the industrial partners and the academics to make sure anything that needs to be in place, like hazard assessments, risk assessments, or anything that are demanded by the legislation applicable to the site is in place. If you look at the legislative changes which are occurring in this country and across Europe, it's driving everybody in the same direction.
We are quite an energy intensive site, so we're then looking to how we can then mitigate and use those carbon emissions that we do create. The other unit we've got is looking at green hydrogen production. We use a lot of hydrogen on site, about 3,000 metre cubed an hour for our processes. At the moment this is made from natural gas in a quite carbon intensive manner. So we're looking to see how we can make that hydrogen greener, how we can make it without carbon emissions attached to it.
The units are there as a demonstration. In reality, we're not going to start taking huge percentages off their carbon emissions. We're not going to start making huge percentage changes to their balance sheet. What we're there to do is to prove that we can use this technology effectively on their site. So the technology is modular. It's an alkaline electrolyzer that fits into a shipping container, and we can build the shipping containers here or build the equipment inside a shipping container here, and we can deploy them to the industrial site.
The scale up is actually quite easy. That box can be moved into any facility anywhere on the basis of a forklift truck, a large-scale truck, or it could be slung underneath a Chinook helicopter and dropped anywhere else if it was for a humanitarian factory. So our next trip in towards the valley of death of innovation is to say, well, we can't just stop there. We've now got to look at what does a commercial product look like. So the industrialists are hard-nosed. They don't like prototypes being put into their facilities because they tend to take a lot of management and they could go wrong. Because we know our solutions aren't going wrong, they've been proven they're process capable, then the industrialist wants to know, well, how much does it cost me to run that? What benefits do I get? Can I extract a profit stream from what I've got? Because we don't currently, you work that stream, but your machine's going to give me that byproduct that I can then sell, and I could sell it to another sector. At that point, the industrialist can satisfy some boxes. 1, I've got good operational costs. 2, I've got a solution to an environmental problem. 3, I can tell people about that solution because that helps sell my brand, my story, my credibility as an environmentally friendly, forward-thinking organisation.
You know, whichever way you're telling the story and through whichever vehicle, you must remember that you're doing it for a purpose. When you're in business, you're doing it for a purpose. There is a desired outcome. But the environmental perspective of a business and its sustainability credentials have become necessary to be in the game.
Communication is everything. And one of the problems scientists have is, in general, we're horrible at communicating things. We're great at persuading ourselves why things are great. But we're very bad at telling the general public.
Story is one of those openings that we have as cultural beings to begin to enter into some form of understanding. We've incorporated storytelling into the design of this project.
To have a storyteller that's there from near enough conception of the project and working through as the project develops, I think was a really key opportunity and a really interesting way of working. I decided to go the route of filming stories, of being more participatory myself. So I would interview people, I would film them, and I would film where they worked and film the context. One of the interviews that I conducted for the RISE project was with George Marshall, who's a specialist in climate change communication. And he talks about climate change as a wicked problem.
A problem that you can't immediately see as being a problem because it's so strongly interconnected.
With wicked problems, there aren't one solution. There aren't singular solutions which you can just hold up and say, do this, it solves the problem.
And that is where story and storytelling and communications are the critical medium through which people interpret this issue.
Nurturing people to love their square mile more. And if we love something, we start to think differently about it. We don't vandalise it at a basic level. We start to care for it. We start to invest in it and in its community. And at the upper level, we start to think about that local context within the context of the whole planet. And if we sort out the rubbish and the kind of, the waste product in our locality, then if we're doing that, and if the place down the road is doing that, and a few miles down the road is doing that, then it all begins to make a difference.
The scientists, the people in this orbit of this rice project, they're working at coming to some kind of fruitful accommodation between the interests of industry, which are economic and have to do with continuity, and the interests of the planet as a whole and the civilization that underpins it, and also their own interests as creative people looking for solutions to immediate social problems. And then our role as storytellers is to try and tell that whole story. We're pulling apart and pulling together. Pulling apart because of the differences in our economic and social interests and political interests and scientific interests. And we're pulling together because we're one people, ultimately. When I first moved to South Wales in 2017, I went up to the Valleys campus in Treforest. And the first place I went was the administrative suite in Treforest. And as I walked in the door, my attention was arrested by a porthole in the floor that was emitting light. And I said to the administrative aide, "What on earth is that?" And she said, "Oh, that's the Druid altarpiece of Francis Crochet's." And she explained that the house that was now the centerpiece of the university had been built by the original iron master of Treforest, Francis Crochet's, whose family built the ironworks and started the first coal mines in the valleys. And he was also, as well as a power player in early Welsh industry, he was also a Druid. Now, what does that have to do with our rice project? Druidry is essentially about transformation, about energetic transformation of the land, using the powers that are kind of unconscious and resident in the landscape. And the rice project is about transformation. It's about taking the powers that are in not only the land, that is the powers of iron and steel and coal and concrete, but also the powers of transformation in the human imagination. And to figure out ways to clean up that energetic relationship between us, the things that power our lives, and the things in our environment that support our living. Now, in that same spirit, on the Tata Steel campus, there's a stone wall. And that stone wall was part of the monastery that was built there in the 13th century, back when Wales was a kind of a center of learning and study of spirituality and philosophy. But there's still a power to that place that Wales has always maintained. And that power burst out, I'd say, in the 18th and 19th century.
In some ways, I think South Wales has a lot to atone for its past sins, but it also has a massive opportunity. Because it is no longer the source of fossil fuels, it has the opportunity to say, well, we know how to do that. Now let's try and do it with something else. So let's just call carbon dioxide. CO2 is going to be the new coal. Right? And everything in industry in Wales, back several hundred years ago, was aimed around the coal industry. Everything was. The steel industry, the copper industry, everything else was because of coal. Well, fine. Let's say CO2 is the new coal. Everything should be arranged around that. All the technology, all the developments, everything should be focused around that. I think that's the opportunity that we've got. Windmills are wonderful at making electricity. They're useless at everything else. Can't make food, can't make plastics, can't make carpet, can't make clothing, can't make pharmaceutical. Sorry, they just make electricity. So the reason that the oil industry is successful is not because they make petrol and gasoline. It's because they make a billion other products, because they make the molecules that everyone uses to make all these other products. If we're going to do the same with CO2, you have to prove the same approach. And that's what Rice's biorefinery is about. There are other bioreactors with big ponds and other styles which will make, large-scale absorption of CO2 and then will make a crude fuel, for example. The reason we've done the design of the bioreactor that is at Valley is that what's called a closed system. If we're going to take those products that we make and sell to the pharmaceutical industry or the personal care industry or the food industry, we need to control the purity of the whole process. One of the things that Alan Goui's group is doing is using a different type of electrolyzer, and their goal is to install one at Welsh Water.
We are trying to demonstrate that the oxy-high water process is more efficient than the conventional aerobic treatment that is currently in place in most wastewater treatment plants.
So what the water industry really wants is a process that doesn't actually produce as much solids. They don't have to tanker that away. And so this process, oxy-high water, that we've developed looks to achieve that. We are coupling our hydrogen generation work here, which is using photovoltaics or other renewables to split water to make hydrogen and oxygen. And ordinarily, the oxygen is just wasted to atmosphere. And if we can put that oxygen into a reactor, we think we can improve efficiencies dramatically. We can at least get 10 times smaller plants and possibly up to 100. And that means that we can shrink the large sewage treatment plants to a tank which has got a much smaller footprint, and that allows us to put a lid on it. And in doing so, we can control the efficiencies.
So when you're taking electricity, which could be from Welsh Water, say, or it could be from any other source, you're generating a transportation fuel, you're making the environment cleaner, and you're enhancing water treatment facilities. So there's an example where what your fundamental role is to take electricity and generate a transportation fuel. Your side product is you're changing how the water industry cleans water. One of the things that people talk a lot about is the circular economy. I think that's a dangerous phrase to use because people then think it's only just about recycling something. We need to think of it more in terms of where there's a missing link.
All of what we're trying to do is in some way connected. The future vision is very much one of a symbiosis or a linkage between industry and community, industry and providing new industry opportunities alongside that.
All these interlocking things, it's a very, very complicated picture, but it's a tapestry. And you can unpick each of those threads and you can look at a thread and in itself it's a story worth telling. Or you can weave them all together and start to look at the bigger picture.
Everything is interconnected. Circular economy is not necessarily one circle, it's many different circles, and that's what we should be able to learn from nature. If you have diversity, you will have a stable system that can take a lot of different stresses.
I think the natural world and the processes that it has inherent in it, there's a lot of lessons there that we can draw on. We are not separate from nature, we are of nature, and we rely on the natural environment for all the resources that we turn into cars and TVs and phones and clothes and food.
Seeing what plants are doing makes me think, what are we doing and where does the story continue? To make something look carbon neutral and be carbon neutral are two different things, because to make something be carbon neutral, you have to include the manufacturing process, which is where I'm getting very scared. We're using pneumatic valves, not electric valves, but then the manufacturing process of these valves has to be taken into account to see if we are reaching a net zero.
When we try to solve a problem, you find a solution to it, there's a huge possibility there will be some byproduct problems. So you have to be careful of what other issues can arise from that solution of yours.
But it is a beginning and we have to start somewhere. So sometimes I'm scared, sometimes I'm hopeful.
We really need to instill in the population, and especially children, is this is your chance. This is a challenge. Are you going to meet that challenge?
Yeah, I mean, the challenge of decarbonisation is massive, right? There is no one single answer. And the trick to the future is to have a lot of options on the table at your disposal. And the more of those we can consider, the more likely we are to come up with one that provides a real solution.
I don't think you can just leave it to the free market. There needs to be some incentive to sort of give it the kick start. It always takes longer than you expect.
As much as we talk about saving the planet, we're not trying to save the planet. We're trying to save ourselves. The planet was here before us and will still be here when we've gone. When we are trying to address climate change, that is what we are trying to do, is maintain a planet that's habitable for us. And in doing that, we need to maintain a planet that's habitable for the trees and the grass and the systems that we rely on for our raw materials and the substance of life.
But the transformative power of the land, whether we call it the Druid imagination or we call it the resources that are here, natural resources, cultural resources, scientific resources, imaginative resources, they're always there for us to draw on and to follow into that other world, which is our potential, our future.